Today's video will just be looking at one example, and we'll be looking at it in general terms of a radius r, so without an actual number in there, which is sometimes tricky for people to work with. So we're going to find the area of the largest rectangle, so we want to maximize the area of a rectangle that can be inscribed in a semicircle of radius r. So inscribed means the vertices are sitting on the semicircle. So here's what a picture of that would look like. We're going to say our semicircle is the top half of a circle with radius r, and the center being at the origin. The reason for doing this, it'll make our equation of this semicircle kind of nice. It's just x squared plus y squared equals r squared. Now, for the dimensions of our rectangle, whenever you have a coordinate, the x value tells you how much you're moving left and right, and the y value tells you what you're moving up and down. So because the y value tells you what you're moving up and down, our height of our rectangle is just y. That's the distance that you moved off of the x-axis. And the distance that you moved from the y-axis is just x. And that's an important concept that will come up quite a bit in one of our more challenging units at the end of the year. If you're moving just off the x-axis, that's just your y value. And if you're moving off the y-axis, that's just your x value. Now, this side here is that same amount, x. So in reality, the whole length there of the rectangle is just 2x. So the two equations we'll work with, we've got our equation of the semicircle x squared plus y squared equals r squared, and then we'll set up an equation for the area of the semicircle. Since the area of the semicircle is what we're trying to maximize, that's what we'll eventually plug into. So it's just a rectangle, so it's length times width. Well, the length is represented by 2x, and the width is represented by y. So area is just equal to 2x times y. And what we'll do is we'll get one of our variables by itself in our semicircle equation. Let's maybe get x by itself, so we'll subtract the y squared over. We'll have x squared equals r squared minus y squared. And we'll take the square root of both sides to get that x is equal to square root of r squared minus y squared. When we sub that in for x, we'll get a is equal to 2 times the square root of r squared minus y squared times y. And to neaten that up, let's just write the 2 and the y out front together. And we'll put the r squared minus y squared in parentheses raised to the 1/2. Now, it is important to remember r is some constant value. It's like a 7 or a 12 or a 23. Okay, we don't know what it is, but it's some number that's staying put. It's not a variable. Because it's a constant, we need to treat it like we would a regular old number when we are taking the derivative. We are going to have product rule here. We'll think of one of the things as 2y, and we'll think of the other one as our parenthesis there. So we'll do our derivative a prime. So to start out, we'll do derivative of the first part times regular of the second. So we'll get 2 times r squared minus y squared to the 1/2. Plus, because it's product rule, we'll do regular of the first times derivative of the second. So derivative of the second, we'll have 1/2, keep the inside the same, raised to the minus 1/2, times the derivative of the inside. Now, here's where people often have trouble with it. Keep in mind, r is a constant. So r squared is a single number. It's not changing. We need to treat r like we would a number, like a 7. So the derivative of r squared is just 0. It's a constant. The derivative of negative y squared, y is what we're taking the derivative with respect to, so that derivative is negative 2y. And we'll try to neaten this up some. A prime is going to end up being 0. This will give us 2 square root of r squared minus y squared. We're going to have a 2y times a half, which will give us y, times a negative 2y, which will give us negative 2y squared. So we'll have minus, and then we'll do 2y squared, and then we'll put the square root on the bottom. And now because r is a constant, our answer is going to be in terms of r. So it's okay to still have r's in our answer. And we're going to work to get y by itself. So let's add that negative fraction over, and we'll get 2y squared over square root of r squared minus y squared is equal to 2 square root of r squared minus y squared. You can think of that over 1, and we can cross multiply. So we'll get 2y squared equals 2, and then square root times the square root is just itself. So that's r squared minus y squared. We can divide both sides by 2, and we'll get y squared equals r squared minus y squared. Keep in mind we're trying to solve for y, so we want to get the y's together. We'll add the y squared over to the other side, giving us 2y squared equals r squared. We'll divide both sides by 2 to give us y squared is equal to r squared over 2. And when we take the square root, we'll have y equals the square root of r squared over 2, which is the same as saying that y is equal to r over the square root of 2. Now, you may be asking, why do we not need the plus minus? We chose to think of it as the y, or the semicircle being in the top half, so the y values are then positive. You'll get the same area if you chose to draw the semicircle in the bottom half, because we're going to be plugging it into the circle formula. It's going to get squared anyway, and we're looking for the area of it. So if you had chosen to draw it in the bottom half, you would end up with the same answer in the long run. So knowing that y is equal to r over square root of 2, let's go back to what we knew our area was here, and we'll bring that down. We knew that the area was equal to 2y square root of r squared minus y squared. Keeping in mind still that our answer is going to have r's in it. It's going to be in terms of r. Let's sub in for y. We knew that y, the neat version, was r over square root of 2, so we'll plug that in. We'll have the area is equal to 2 times r over the square root of 2 times the square root of r squared minus r over the square root of 2 squared. This will give us 2r over square root of 2 times, under the radical, we'll have, I'm going to write it as 1r squared to start, and you'll see why I'm going to do that eventually, minus, we've got to square both things. So we'll square the numerator, and you get r squared. Square the denominator, square root of 2 squared is just 2. Well, that's like saying minus 1/2 r squared. So a is now equal to 2r over square root of 2 times the square root of 1r squared minus 1/2 r squared gives us 1/2 r squared. Well, that's a equals 2r over square root of 2 times, this part is the same as saying r over square root of 2. Square root of r squared is r, square root of 2 is 2. Multiplying this out, we'll get 2r squared. Square root of 2 times square root of 2 is 2. So in the end, we get that our maximized area is, in fact, just r squared, which is kind of neat that it ends up so nice. Again, r was a constant. It was some given number. Because it was constant, when we went through and took the derivative, we had to treat it like a constant. A derivative of an r would just be 0. And in the end, our area is whatever r was squared. That's all for today's video. We'll see you next class, period.